All right, good morning and welcome to today's webinar, How to Qualify Standard Libraries in Safety Critical Applications. I am your host, Alicia McCullough. Our presenters today are Derek Opitz, Senior Field Applications Engineer, Team Lead for Vector North America, and Remy Van, Qualification Lead Engineer for Solid Sands. We will have time after the presentation for questions. So please type any questions you have into the Q&A window at any time, and we will answer them at the end during the Q&A. Please use the chat window that is separate from the Q&A window if you have any comments or concerns for me directly. If you miss any part of the presentation today, a recording will be made available. When you leave the webinar, an online survey will pop up in your browser. We ask that you please take a moment to fill this out. Your feedback is very important to us, and we appreciate that. And with that said, I'm going to turn things over to Derek. Derek?
Thank you, Alicia. And good morning, everyone. Today, we're going to talk about how to qualify standard libraries in safety critical applications. I'm going to give an overview of VectorCAST QA, which is going to be used for the code coverage portion of the demo that Remy's going to do later, and then Remy's going to present some slides over Solid Sands library test suite, and also do a demo showing the combination of Solid Sands library test suite and the VectorCAST QA. So let's get started. So when we talk about how VectorCAST, we typically start with the V model. And on the left-hand side of the V model, you have your design phase. And then on the right-hand side, you have your testing phase. VectorCAST provides solutions for all phases of testing, all the way up from unit testing, all the way up to the very top levels of your testing, whether it's system testing or functional testing or V&V testing. VectorCAST provides solutions for all parts of the testing V model. So here's a deeper dive into the V model, and this shows you the right-hand side of the V model right here, starting at the bottom with static code analysis and going through software unit test all the way up to system validation. And you can see we have a little description here of each type of testing. So for software unit testing and software integration testing, typically that's a white box testing type application, and you're looking for a test solution and also code coverage on your host or your target processor. And this is where VectorCAST C++ comes into play. That's our unit test tool. And then as you get further up the V model, you get into your software system testing, and that's where a lot of the other vector tools come into play, like Canoe and VTest Studio, and also VectorCAST QA, which is what we're going to focus on today. And then once you get up into the hardware software integration testing and the system validation, you see the Vector has solutions for all that type of testing as well with our Canoe, VTest Studio, VT system, and then one we're going to talk about today, which is VectorCAST QA. And notice here, there's this link to requirements. So VectorCAST, along Vector in general and VectorCAST, provide a mechanism so that you can link any of these types of testing to your requirements. So we provide what we call a requirements gateway that allows you to link your tests with your requirements. And then we also have a product called Score, which provides you with metrics and analytics during all phases of your testing. So let's talk a little bit about VectorCAST and what our product strategy is. First and foremost, we are designed as an embedded test tool. Embedded systems are different. They typically use a cross-compiler. You know, if you're compiling, you may be on a Windows host, but you may be compiling for an ARM board or compiling for some other PowerPC board. VectorCAST is designed to use the exact same compiler that you're using in your system. The same compiler flags, the same defines, preprocessor flags, all those sort of things. Embedded systems also need some sort of device to be able to load code and debug code on a target, usually it's a JTAG or an emulator or something like that. And VectorCAST tightly integrates with all of those type of JTAGs and emulators to allow you to, in an automated fashion, test on your target. We integrate tightly with your embedded system in your project. So we focus on embedded systems. We were designed for embedded systems. We also have put a big focus on continuous test. You know, there's a lot of CI tools out there. They're very, very popular right now, the Jenkins, the Bamboos, the Git runners. And so VectorCAST integrates with all of those CI tools. And it enables you to do continuous and collaborative testing. The more often you test, the easier it is to find bugs. And so we've enabled, we put a big focus on enabling you to do CI testing. And then automation. All of our tools are designed to be automated. Our unit test tool is designed so that we can automate our testing on your embedded system. Our QA tool is fully automatable as well. We have a full command line interface, so you can integrate that into your build infrastructure. You can integrate that into your test framework. And VectorCAST is designed to be fully automated. And then, because we integrate with all your existing workflows and tools, and we try to make our tool easy to use, we try to be the tool of choice for developers, because we try to make it as easy as possible to use your existing test framework and your existing build infrastructure and your existing project with VectorCAST, and to make it easy for developers to use. So let's talk a little bit about system testing. This is the main area for VectorCAST QA. It can also be used at the software integration testing, and we're going to see later that you can also use it for library testing when Remy gets to his demo. First and foremost, VectorCAST QA is a code coverage tool. So you instrument your code with VectorCAST, and we tell you your code coverage during all your testing. There's a lot of different purposes for that code coverage. You know, the main one is how it's testing completeness. How complete is your testing? We also integrate with all the existing test frameworks, as we talked about. So we have a full command line interface, so we can integrate in with your test frameworks. And then we also provide a mechanism for white box system testing. So not only do you get the code coverage metrics, but VectorCAST has probe points that allow you to insert test code anywhere in your system that you want. So therefore, you can run your system testing in more of a white box fashion, and you can monitor anything in your code, in your software that you want to be able to monitor. It allows you some pretty neat white box functionality along with your system testing. And then we have the concept of change-based testing. VectorCAST can determine, based on the previous runs, what tests need to be reran when code changes. So you have a code base, you run all of your tests, you make some code changes, and you want to know, I've got 100 tests, 200 tests, how many of those tests need to be reran based on these code changes? Well, VectorCAST can tell you that. And then you can focus on just running those tests instead of having to run your complete suite of tests. And then we have a covered by analysis portion to VectorCAST QA. A lot of times when you're doing testing, there's going to be code that you just cannot test in the software, whether it's some error condition that you can't get to, or it's defensive coding, or it's just some code that's very, very hard to test. A lot of times you're not going to get that 100% code coverage, and so VectorCAST provides you with the mechanism to analyze your code, provide a analysis of why you need that code in there and what the code does, and also link that analysis to a requirement. And all that is rolled up into the QA reporting, so you get all of your code coverage and test results and covered by analysis all in one location in one report. And then, as we mentioned before, requirements gateway. VectorCAST at all levels in the V model allow you to link your tests to requirements, and it's a two-way street. We can import requirements from your tool, from your requirements tool, and then link those to test cases, and then we can export those test results back to your requirements tool so that you can see inside of your requirements tool what tests are linked to those requirements and what the test results are for those tests. So it's a two-way street, the requirements gateway is. So VectorCAST QA. As you can see, we tightly integrate into your build system. We tightly integrate into your test infrastructure. So we can use the build settings that you have to instrument your code, and then we can integrate into VectorCAST into your test infrastructure. So the running of the tests with instrumentation, the obtaining of the test results, all those sort of things can be integrated into your test infrastructure. So then when you combine your build system with VectorCAST QA and your test infrastructure, at the end result is you get your source code metrics, you get your test pass-fail status, you get your code coverage metrics as output from VectorCAST QA. And all of this is done in an automated fashion. And because everyone's looking for automation, no one wants to do manual testing, and so we've designed VectorCAST to easily be automated and integrated into your build and test infrastructure. So let's talk a little bit about how VectorCAST QA works. So first of all, as we mentioned on the previous slide, it integrates into your build system and your existing test infrastructure. We use your compiler tools to instrument the code. We leverage your existing tests to provide code coverage metrics, and we have a command line interface that allows you to do all of that in an automated and integrated fashion. No changes to existing workflow or tools are required. We integrate directly into your current workflow and your current tools. And I want to mention that we have a VectorCAST C++ tool, which is a unit test tool, and it is a test authoring tool. VectorCAST QA is not a test authoring tool. It provides you metrics for your testing, but we rely on your existing test framework to do the testing. And then down here is a simple example of how we instrument your code. We add these macros in here that just flip bits of memory that tell you they can track your code. So as you're going through your code, running on your target, we just flip bits of memory. Been here, been here, been here, been here, and that's how we track that your code coverage. And then at the end of the test, you have all these array of binary data on your target, and then we just pull that off with some either a standard out, CAN or serial or some other device, or we can just grab it directly out of memory with a debugger. So there's a number of ways to get that data off your target. And again, we integrate in with your existing workflow so you don't have to make any changes to the way you normally do things. So here's a big picture view of how VectorCAST QA works. So we take your source code, we instrument that source code with VectorCAST, then we use your build infrastructure, whether you have some sort of custom IDE or you have just a make infrastructure. You use that same build infrastructure to build and link that instrumented code into your test executable. So just like you normally do, except you're going to be using instrumented code. And then just like you normally do for your test infrastructure now, you load that test executable onto your target, onto your simulator, you run your tests, and then VectorCAST gathers up or tracks the code coverage. And then, as I mentioned in the previous slide, we have to get that code coverage information off of your target. We can do that through file I/O, we can do that through Ethernet, serial, JTAG, whatever mechanism you have for getting data off your target, we can use that. And then we roll all that data up into coverage reports, and also metrics reports, and we can also do test pass-fail status, those sort of things as well. So that wraps up the VectorCAST QA presentation. I'm going to pass it back to Alicia, and she can hand a presentation off to Remy.
Okay.
So thank you, Derek. Very nice introduction to VectorCAST. And hello, everybody. Let me start with a short introduction about Solid Sands. So we are an Amsterdam-based company in the Netherlands, and we are the one-stop shop for C and C++ compiler and library testing, but also for validation and safety services. So over the years, we have supported many companies with the qualification of their toolchain for safety-critical projects. And yeah, we have a lot of experience in compiler and library qualification, for example. So here's an overview of our products. Probably our best known product is the Supertest compiler test and validation suite, which is a comprehensive suite of both handcrafted and generated tests that are based on the ISO C and C++ specifications. So Supertest, it allows you to qualify any C or C++ compiler for your specific use case within a safety critical project. In the graphic on the right, you can see all the language versions that Supertest supports. So that ranges from C90 all the way up to C++17. And also since C++20 was recently released, we are currently working hard on completing our C++20 test suite. Related to the Supertest compiler test and validation suite is the Supertest standard library suite. So since the C and C++ standard library is also defined as part of the ISO C and C++ specification, the Supertest standard library suite can be used to test an implementation of the standard library as well. Since the standard library is the main focus of the presentation today, I will go on into more detail in the next slides. We also offer the Supertest MISRA compliance suite that can be used to qualify MISRA guideline checking software. So the MISRA compliance suite is a large collection of files that are either MISRA compliant or that violate specific MISRA rules. And then using this test suite, you can verify that your MISRA checking software gives you proper warnings for MISRA violations, but also that it does not give false positives for any MISRA compliant code. Then finally, there's the CG Trainer or Code Generator Trainer. This is a product that supports the development of new compiler backends. And it contains a lot of code examples at increasingly difficult levels in such a way that you can step-by-step implement more features into the compiler backend. So this is a great first step test suite when starting on a new compiler, and after that you can then do some more comprehensive testing using Supertest. Like I said, today we will focus on the standard library and more importantly into the qualification of the standard library for functional safety. And this is very important because just like any other part of your application, the library consists of code that will become part of your application and that will be loaded into your safety critical device. So this means that if a library component contains some incorrect code, its safety risk can just be as big as for any other part of the application that you develop yourself. So because of this, all functional safety standards require the library to be qualified. Examples are the IEC 61508 industrial standard, the ISO 26262 automotive standard, and the EN 50128 rail standard. Today, we will dive into the requirements of the ISO 26262 standard in particular, but all of that also applies more or less in the same way to the other functional safety standards. So in ISO 26262, Section 12 of Part 8 focuses on the qualification of software components. So this applies to existing software that was not developed according to ISO 26262, but that still needs to be used within a safety critical project. Most importantly, this section applies to software libraries that come from third-party supplier, which is also named commercial off-the-shelf software. And of course, the standard library is an important example of such third-party supplied software. So the standard library is often hugely relied on by software developers. It usually comes from a third party, and it's usually not developed according to ISO 26262. So this section of the standard, it defines a long list of what the specification of the qualification should include. For example, a unique identifier for the software component that is being qualified. In case of the library, that would be the name of the library implementation and a specific version number, for example. But also the maximum safety level that the qualification applies to is important to be specified, since it might affect the qualification efforts that need to be done. Most importantly, the specification should include the requirements of the software component that is being qualified. And in case of the standard library, those are the requirements that describe the functionality of the library. So the qualification should verify that those requirements are correctly being implemented. Also, a description of known issues with corresponding workarounds should be specified. These can be obtained during the qualification process, but they can also be retrieved maybe at the start of the project from the supplier of the library who might have already a list of known issues, for example. So now we have looked at what should be part of the specification of the qualification. Let's now look at the actual qualification efforts that need to be performed. So most importantly, the requirements of the standard library that we talked about They need to be defined and they need to be covered by testing. So this testing is primarily based on requirements-based testing, and it needs to be done in accordance with Part 6 of ISO 26262. And Part 6 that describes software development practices, and a part of that also describes how to write and develop requirements-based tests. In terms of actually defining the requirements of the standard library, well, there's good news and there's bad news. So the good news is that there is a list of what the library should be doing in the C library specification, of course. But the bad news is that this is not a straightforward list of requirements. So the specification, it does accurately describe all the library functions, but it does not provide you with a list of requirements. So there's still quite a lot of work involved in turning these descriptions into actual requirements. And I will give an example of that later on. ISO 26262, it also defines that requirements-based tests should cover both normal conditions and the behavior in case of failure. So this means that you should not only test the library functions with correct inputs, but also with potential wrong inputs and then verify that this correctly is being handled by the implementation. So for example, a function that writes text to a file, that should not only be tested with a file that is actually writable, but also with a file that cannot be written to. And then it should be verified that this is correctly being handled by the library implementation. And if it, for example, returns a value that notifies the application developer that something went wrong. In case you are qualifying for ASIL D, which is the highest automotive safety integrity level, you should also, in addition to the requirements-based testing, you should also analyze structural code coverage. This way you can analyze whether all of the library was properly covered by testing, and this shows additional evidence that in addition to the requirements coverage, also you have completeness in terms of code coverage. So in the graphic on the right, you see how this all fits into the V model that Derek just talked about. So we are at the integration level. That is what we are talking about. And then finally, when you have performed all these qualification efforts, they should all be documented. So the requirements, they should be clearly documented. All the test results should be documented. And of course, potential errors should also be described. And if possible, with corresponding workarounds. In case of ASIL D, also the structural code coverage results need to be documented. And after you have done all that, the standard library is qualified for use in safety critical projects. So while I was talking about all these library qualification efforts, yeah, you might have become a little bit overwhelmed. I mean, defining library requirements and developing proper tests, that is a huge project on its own. And yeah, that's not something you want to do in addition to all the efforts of developing and testing your own safety critical software. But you can be relieved since with Solid Sense, we have been working hard on making our standard library test suite an out-of-the-box solution for library qualification for functional safety as well. So this is a new product that will be announced soon. Today, I'm giving you a little sneak preview of what you can expect from it. But yeah, make sure to keep an eye out for the official announcement, which will be coming soon. So like I said, this new product, it builds on top of the standard library test suites that we have already available for many years. And what we have added now is everything needed to qualify a standard library implementation for functional safety. Most importantly, we broke down the C specification into separate testable implementation requirements. And then along with these requirements, we provide test specifications that describe how a test is implemented to verify that the requirement is met by the library. All of our test cases are developed in accordance with Part 6 of ISO 26262. And out of the box, we already achieve high structural code coverage on library implementations. Finally, we will provide a software tool that provides documentation with all the requirements that have been tested and whether they have been met or not met by the implementation. So that way you can easily document all your testing efforts and the corresponding results. And later on, I will give you an example of what it actually looks like. So as I just explained, we had to break down the C specification into separate requirements. And that's needed because the specification itself is not broken down that way. And here we see an example of the f_c function. This is a function that writes a character to the output stream. And based on the paragraph numbers that you see here, you might think that there are only 2 requirements on this function. Because paragraph with the number 1, that only defines the prototype of the function. And then there are 2 additional paragraphs that might look like 2 separate requirements. However, if we take a closer look at this, we can actually break this down into 7 different requirements. So yeah, let's do that. So here from the first sentence, we can extract the first requirement, and that states that the function should write the character that is specified to the output stream at the position indicated by the associated file position indicator for the stream. We give this requirement a unique identifier, so it can be clearly documented, and you can also link it to the actual test that is being performed. But as you now already have seen, we have only read a part of the first section, and we have already extracted 1 requirement. So we can go on to extract more requirements. So here it is stated that the function should advance the indicator appropriately after writing to the output stream. Going on, there's also stated that if the file cannot support positioning requests, the character should be appended to the output stream. But also, if the stream is opened in append mode, the character should also be appended to the output stream. In the next section, we can go on. So here we have another requirement that states the f_c function should return the character that was written. And it also specifies 2 requirements in case of an error occurs. In that case, the error indicator for the stream should be set, and the function should return end of file as the return value instead of the character that was written. So as we have seen, we have now extracted 7 different requirements from these 2 very small paragraphs. It's actually only 4 sentences. But yeah, this really demonstrates why it is not that straightforward to take the standard and just start testing based on the standard. You really need an intermediate step by translating the standard into separate testable requirements. Now, after this, the next step is actually creating test specifications for these requirements and, of course, implementing those tests. So let's take a look at some examples of that. Here's the requirement with the name success, which we saw before. But this requirement states that the f_c function should return the character that it has written in case of success. And the corresponding test specification states that each time the function is called with a file pointer that is open for writing, so that means we can actually do the writing to the file, we should check that the character that is passed as the first argument to the function is also the value that is being returned by the function. Then, based on this, an actual test is being implemented, and of course that was exactly what is described by the test specification. So by having the requirement and the test specification defined, it is now clear what is being tested, and that is both useful for yourself when you're analyzing what the library test suite is doing, but more importantly for your functional safety auditors. This is what they want as the proof how you have been doing your testing, and to analyze whether the testing is actually good enough. So let's take a look at another example, and this is then testing in case of an error, which was also defined by the ISO 26262 standard that is required to do. So here we see the requirement EOF that states that if a write error occurs, the f_c function should return EOF, or end of file. So in the test specification for this requirement, we first make sure that the error conditions are met, and we do that by generating a write error by calling this function with a file pointer that is open for reading, so it cannot be written to. And then we verify that the function returns EOF instead of the character that should have been written by the function, or that we requested to be written by the function. So this gives you a little idea of how we turn the requirements into actual test specifications and then the corresponding tests in our test suite. And using these requirements and the test specifications and the actual tests, you can qualify the standard library that you are using for use in a safety critical project. The final step is then documenting these efforts using our documentation tool. So let's take a look at that now. So this is how everything comes together. Our reporting tool analyzes the test results of running the library test suite. And for each requirement, it documents both the requirement and the corresponding test specification, and also the name of the test that implements this test specification. So for each of them, the tool reports whether the test has passed or if it has failed. And that way you can clearly see if the library function is correctly being implemented and safe to be used within a project. So like I said, this information is generated by our documentation tool. And yeah, today we're giving you a sneak preview, so make sure to keep an eye out for the official announcement, because I'm sure this will be helpful for many of you looking for a solution qualifying your standard library. Now, there's one detail of the qualification that we have not looked at yet, and that is structural code coverage. So like I said, in ASIL-D, the highest integrity level for automotive software, this is required by the functional safety standard. And the main purpose of code coverage analysis is evaluating the completeness of your test cases. So missing code coverage, that probably indicates that there are tests missing, maybe for special edge cases or for implementation defined behavior that cannot be tested by a generic test suite like ours. And of course, this is important to be aware of, because missing code coverage might mean that you're not testing some important parts of your library implementation. So at the same time, this means that also for other ASIL levels, so lower safety levels, this is relevant information, because test completeness is of course always important to be aware of. Now, ISO 26262 requires MCDC, or modified decision condition coverage. And of course, like Derek already mentioned, VectorCAST QA is a great tool for analyzing structural code coverage. And that's why we have used it during the development of our test suite as well. Here's an example of why code coverage analysis is so important, also while developing a test suite for the standard library. And that's why we have used it during the development of our test as well. So here we see a description of the FREXP function in the C library. And what that function does, it breaks down a floating point number into a normalized fraction and an integral power of 2. Now, based on the description of the function and the requirements that we base on it, we might select 3 equivalence clauses that make sense to be used while testing this function. And that would then be a positive floating point number, a negative floating point number, and 0. And yeah, maybe this already looks like we are now covering all the implementation details. But if we take a closer look at the actual implementation and the corresponding code coverage of these 3 test cases, we will see that this is not quite the case. So here on the right, we see some coverage results from VectorCAST. We see green bars indicating we have full coverage of those lines, but we also see orange and red bars indicating that we have some missing code coverage. So the first piece of missing coverage is over here. Here the function FREXP is being called recursively, and also the exponent is being decremented by 64. After analysis, it turns out this is a special case that handles subnormal floating point values. And subnormal floating point values, they are a special representation of floating point values that needs to be handled in a different way. So based on the description of the function, this is very easy to overlook, because the description of the function just says what should be happening for any floating point value. But as it turns out, when implementing this, there are different ways of handling the different floating point representations. So we should definitely add a test case for this. The other piece of missing coverage is over here, which handles the not a number and infinity floating point values, which are some special values in floating points. And of course, also for that, test cases need to be added. So based on these coverage results, we add a test for the special boundary values, not a number and infinity. But also we add the equivalence clause of subnormal floating point value. And now when doing the coverage analysis again, we see we achieve complete structural code coverage that demonstrates that we do not only, in terms of the requirements, fully test the function, but also in terms of the actual implementation detail. So recently, Solid Science and Vector have been working together on integrating library testing and structural code coverage analysis into a single out-of-the-box solution. And here our goal is to make library qualification as straightforward as possible. So I think now it's time for a live demo where you can actually see how our test suites and VectorCAST QA integrate and how easy it is to get started with library qualification yourself. So for that, let me switch over to VectorCAST. So for demonstration purposes here, I am showing you the VectorCAST QA graphical user interface. But like Derek already explained, everything I will be showing here is also possible to do from the command line. So that means you could, for example, easily integrate this into your continuous integration setup if you would like to do that. But yeah, for the demo, I will be using the graphical user interface. So over here, I created an example project of a C library implementation that we will instrument to do MCDC coverage analysis using VectorCAST. I'm using the open source Muscle C library implementation to do that. So the Muscle C library implementation is a nice and clean implementation that is structured very nicely as well, since every library function has its own source file. So that makes it very easy to look at the coverage today and actually look at some implementations. So as you can see, when I go into the project, I have selected a subset of the library that contains all the functions that are declared in the string.h, the standard-lib.h, and the wchar.h library headers. Of course, our test suites support almost all standard library functions, but I selected these functions because they are relatively easy to understand when looking at their implementation. And also it will save some time if we only do the coverage analysis on a subset of the library instead of on the entire library. So instrumenting the library source files is very straightforward by just right-clicking a source file and selecting instrument. Like Derek already showed, VectorCAST will then parse the source file and insert its coverage instrumentation into the source code. And then using those instrumented source files, you can then build the instrumented library that will be linked to the test suite to analyze the code coverage. So all we need to do now is tell VectorCAST how it can actually build this instrumented library. And we need to tell VectorCAST how it can run our test suite on it. And then we can get started with the coverage analysis. So to do so, every VectorCAST project has a nice and simple Python script that can be configured to do this. So the important variables, they are the location where to run make, which is the location where the library sources are located, and from where we will be building the instrumented library. Also important is the top-level make command. So that is the actual command to build the library. And together, what will be happening now if we ask VectorCAST to create the instrumented version of the library is that a shell will be opened by VectorCAST in this directory. And from there, it will execute the make command. It will then make sure that the instrumented source files are being used instead of the original source files. And that way we obtain the instrumented version of the library. What we should do next is actually tell VectorCAST how it should run the tests that use the instrumented version of the library. So first, we define the location where to run tests. So in this case, this is the directory that contains our test suites. Next, we should define the test cases that we are interested in. So in this case, we tell the Solid Sense test driver it should be using all tests for the string, the standard library, and the wchar library headers. And then finally, we should define how the actual test driver should be invoked by VectorCAST. And that we do over here. So we tell VectorCAST that the command is strun, which is our Solid Sense test driver. We pass the VectorCAST specific configuration file to the test driver. So this makes the test driver aware of the fact that we are using it in combination with VectorCAST. And then, for example, the coverage files will be put into the right directories such that they can be retrieved by VectorCAST again. And then finally, we tell the test driver the different test cases that we are running. And those are the test cases we defined here. Now, normally we would tell VectorCAST to first build the instrumented library. But for this demonstration, I already did that to save some time. So now we can go straight on to actually executing the tests. And like I said, it will be based on what we defined here in this script. So to do that, we go to project and click execute. And as you can now see on the top right here, the SolidSense test driver is being invoked with the VectorCAST specific configuration file, and the different test cases are being used by the test driver. So the convenience of being able to only run a defined set of tests instead of all the library tests is that, of course, you do not have to run the tests that you are not interested in. So for example, there might be some library functions or maybe a lot of library functions that you are not using. Then, of course, it does not really make sense to qualify those because it will be a lot of time wasted that is not interested anyway. So instead, what you could do is at the start of the library qualification project, you could make an inventory of all the library functions that are being used within your application. And then that way you can define a subset of the library that needs to be qualified. Alternatively, you could choose a little bit more flexibility. And in that case, you could, for example, define a set of library headers that is allowed to be used within your project. And then you would only qualify all functions that are related to those specific library headers. So in that case, for example, if your application is still in development, your developers are not tied to a fixed set of functions, but instead they can use all library functions that are in the defined set of library headers. So as we can see, the test running has finished. So we can now go straight into the actual coverage results. So for that, we go into the project again. We select the test cases we are interested in. So those are the standard lib, the string, and the white character. And then already we see in the list of source files over here, a lot of green check marks. So these check marks, they indicate we have 100% MCDC coverage on these source files. However, we also see some green bars. Those indicate some high coverage, but not full coverage. So this might look like we have some missing test coverage and we need to add some additional test cases. However, that is not always the case. So if you, for example, go into this function, the wString compare function, we see on this line, we have some missing coverage. If we click the line, we get a nice MCDC coverage table here at the bottom. And this indicates that in the evaluation of variable R, we are missing a test case where R evaluates to false. So at first thought, it might look like we need to add a test case where R actually does evaluate to false. But if we take a closer look, we will see that that will not fix the code coverage to 100%. So the issue here is that in the comparison, first L and R are being compared to be equal. And only then we will go on to evaluate both L and R. So that means that if L now here evaluates to false, we will jump out of the conditional expression. And we can never reach the stage where R is equal to 0 because that is already catched by the previous evaluation of L. So this demonstrates that even though it might look like we have not 100% coverage, still this is the best coverage we can actually get, and that is caused by the fact of how the code of the library was written. So in such a case, you should really document this and explain in your qualification documentation why the coverage seems to be incomplete, but actually it is still sufficient. Now for the qsort function, we see we have also some missing coverage. This is a bit more complicated because clearly this is a way more complicated function that also contains a lot of sub-functions. So here the effort of analyzing the code and finding out why there is missing coverage, yeah, of course, that is a bit more effort, or actually quite a lot more effort. But really this is an exception from the usual case. So most library functions, they are quite comprehensible. But yeah, it can happen that this is a bit more complicated to actually analyze. Now, the final step after doing all the qualification efforts and analyzing the coverage is generating a coverage report. And also that is possible to do using VectorCAST. So for that, we ask VectorCAST to generate, for example, this metrics report. And then out of that comes an overview of all source files and all functions that are in there with the corresponding coverage. So here we see a lot of green. For the Q sort, we see some lower metrics, but overall we see very high coverage. Here we see some yellow cases, but those are the cases where it is impossible to reach the 100% coverage. So after obtaining this report and analyzing everything, you have now your qualification documentation complete, and you have qualified your library for use within your safety critical project up until ASIL D. So to summarize everything we have talked about and what we have demonstrated, the combined solution of Vector and Solid Sense is basically everything you need for standard library qualification in safety critical product development. So we offer you library tests to comply with functional safety standards, structural code coverage analysis using VectorCAST QA. Out of our tools come detailed reporting, and out of the box VectorCAST and Solid Sense test tools are integrated to make library qualification as straightforward as possible. And with that, I will hand over the mic again to Alicia.
Okay, thank you. We have a lot of questions to get through, so let us begin. The first question is, regarding the standard library approach, how would the change-based testing feature cope with a qualification of this library regarding different compilation options?
Yeah, I think I should answer that question.
Okay.
So I think the change of compiler options, that is actually more related to actual compiler qualification than library qualification. So what is important here is that the compiler that you are actually compiling the library with, that should of course also be qualified for functional safety. After qualifying that, then your concerns are with qualifying the library implementation and not with the compiler options that are used during the library compilation. It's really about the implementation of the library itself then.
Okay, next question. Regarding the qualification of the standard library, for example, C++, STL, how would the tests of the test suite would be matched against the C++ standard?
So how our test cases are structured is that each test is mapped to the specific requirements and also to the specific language and the version of the language. So for each test and for each qualification that you do, you specify the language version you are used, and our documentation tools, they then take care of mapping all the testing and the requirements to the specific C++ or C functions that you have been qualifying. So that way we provide the traceability all the way from the standard defining the library to the actual library implementation and the testing of that.
Okay. Our next question, is the test suite run on the target needed, or is the run on the simulator, for example, QEMU, sufficient for the qualification?
I think that's also something I can answer. So yeah, we do often see that, for example, to make testing and debugging a bit easier, the test run on the simulator. And yes, that is possible. If the simulator is very close to your actual target, then that is a possibility to do.
Okay, I just want to note if everyone could please send their questions into the Q&A window, not the chat window, just so that we can keep track of what's coming in. I appreciate that. Our next question, does Solid Sans provide requirements within its test suite products?
So yeah, like I just presented, we will soon announce a new product that will do exactly that. So over the years, we have already offered, for many years, we have already offered a library test suite, but our new product will now fill the gap of making possible to use that product for functional safety qualifications. And we do that by providing the requirements traceability all the way from the standard to the testing.
Okay, which compilers are supported for the standard C library qualification?
Yeah, I think I can also answer that question. So we support all compilers as long as it is, like you said, a C or C++ compiler. So all our tools, both VectorCAST and the SolidSense test driver, they are very flexible to be configured, so we can handle any toolchain.
Okay, I believe the next one's for Derek. Does VectorCAST provide reports on the test results from Supertest or just the code coverage metrics?
So I think currently the way that REMI has it configured, we're not actually checking the test results. We're just doing the code coverage, but VectorCAST QA can be configured to check the test results from the Supertest if we implement that functionality. So it's possible, but I don't think that's something that REMI implemented.
Okay. Next question, is the sneak product preview also available for C++ test suites?
Yeah, I can answer that. So right now, we are already talking to many companies about C++ as well, because of course there's a high demand for that. But we started with C specifically because C is also a part of C++, so it's a subset of C++. So for C++, we expect not to come up with a full coverage suite, but more let it grow by request and really work together with our customers to implement specific testing. Yeah, basically just because the C++ library is so much bigger and more complicated than the C library. We cannot create one product that solves everything.
Okay. How many tests do you implement for one requirement? The same test can once work and fail another time. For example, another file size or just when it is run another time.
Yeah, so that's a very good point. So of course, for the requirements, we do not only implement one simple test, but we really try to stress the implementation. And part of that also relates to the requirement of ISO 26262 that states that all the testing should be done in accordance with ISO 26262 part 6. So as part of that, for example, you should define equivalence clauses, boundary values, and all of those, of course, they might change the way the function implementation behaves. So of course, yeah, in our test suite, that is taken into account, and we do very elaborate testing of the requirements.
Are the file operations functions like FPUTC relevant for library qualification in case of embedded systems? Or is FPUTC just an arbitrary example, though not directly applicable for embedded systems?
Yeah, so that's a good point. So often in embedded systems, we see of course, that the bare metal or the freestanding version of the C library is used. And then often these kind of functions, they are not part of that version of the library. In the presentation, I use it as an example because it's quite straightforward to understand what is going on. And also it is nice to see and explain how the specification is not a clear list of requirements. So yeah, good point in terms of embedded. This is not always a function that is relevant.
Okay. What is the code coverage, branch coverage for C++ and C library?
Okay, so like I said, for C++, we are currently not offering a complete test suite. So I will focus on C for now. And what we see for C is that for the most functions that are not implementation defined, so for which we can really implement good testing, we reach about 80 up until 100% coverage. So during the demonstration, we saw many of the green check marks, which were indicating 100% coverage, but we also saw some green bars where 80% is a good estimate. And yeah, like we demonstrated, sometimes 80% is the maximum you can actually get, which is then caused by how the function was implemented. And it is sometimes just not possible to get 100% MCDC coverage.
Okay, bear with me on this question. We are trying to get ASIL D for libcxx, the C++ library. We are VectorCAST users already. One option might be to instrument the whole of the Supertest library tests using VectorCAST and use this as qualification evidence for TÜV. Is this feasible?
Yeah, so yeah, this sounds like a feasible approach, with a side note that usually you should not qualify the entire C++ library, but only the part that is relevant to you, so only the part that you are using. And in that case, Solid Sense can work together with you to implement maybe some missing testing that might be there. But already our test suites are, of course, a good starting point and already have quite some good coverage of the C++ standards. So yeah, this sounds like a feasible approach.
Okay. Next question. It's not clear to me what the difference between VectorCAST C, C++, and VectorCAST QA are. Could you elaborate?
Yeah, I'll take this one. So VectorCAST C++ is our unit test tool. And so you're actually authoring tests inside of the unit test tool, and then those tests are then ran on your target or on your simulator or on the host. And now we do provide code coverage during the unit testing as well. So that's the one commonality with VectorCAST QA is both of them provide code coverage. The difference is our unit test tool is a test authoring tool, and VectorCAST QA is not. VectorCAST QA relies on your existing test infrastructure to drive those code coverage metrics. Now, there's a lot of other functionality QA, such as the ability to do some white box testing, and also the ability to check your pass-fail status of tests and those sort of things. But the main difference is that one is a test authoring tool, that's a unit test tool, and one is just relies on your existing test infrastructure.
Okay. Next question. Does the standard library qualification approach apply to other software components as well?
I will take it, but yeah, that's a good question. I think our main focus, of course, is the standard library. Of course, VectorCAST can be used to do coverage analysis on other kinds of software. But in terms of our test suites, we really focus on the standard library, and with our other products on compilers as well.
Okay, and the next question, does Solid Sans provide software component qualification service besides C, C++ standard library?
Yeah, well, like I said, we also offer compiler qualification, and that's actually our bread and butter, which we have done for many years already. So besides library qualification, we also do offer compiler qualification.
Okay, well, we have a lot more questions that came in, but we are out of time. If we did not get to your question, I will have Ramy and Derek go through them and answer them individually and contact you individually with the answers to your questions. I would like to thank Derek and Ramy for your presentations today. Thank you for your time. And thank you all for attending today's webinar. We will be sending out an email to you in a couple of days with a link to today's webinar recording. We ask that you please take a moment to fill out our online survey. It's going to pop up in your browser once you leave the webinar. Your feedback is very important to us, so we appreciate you taking the time to fill that out. If you have any questions or would like to learn more about today's topic, please visit our website at vector.com. Thank you and have a great afternoon.